I think this will be a little bit misleading. I've had it sitting on my desk while I'm editing videos, and the light has finally gone out. I had actually taken it apart because I was going to reprint this a little bit longer so it can go down through there. But if I just give this a quick turn, the light instantly comes back on again. Now, there's no way that that little turn was enough to put power in there to generate that much light. So I think the circuitry turns it off when the voltage drops to a certain level, but there's still power in the battery. So as soon as I did that, that just triggered it and told it got some more power without actually putting more power into it, if that makes sense. So I think that's misleading. I'm going to have to, well, I'm not quite sure what I can do, because if it's going to turn itself off, then we're not going to know whether I've put any more power in there, because it's turning itself back on straight away. I find the on-off switch over there and switch it back on. Yeah, that's coming straight back on again. I think that's the effect, that I'm just effectively turning it back on again by doing the slightest bit there. So we can't really tell how flat it is. I'm going to have to put some sort of load on it to actually flatten the battery, and then see if we can put some charge back into it. Needlessly complicated for a simple little project. Another day. Did a minor bit of change to it. Mainly printed a longer spike or peg to go down through there, so we can have the peg going through the top of the handle. Printed a new peg for that one, because that one had started to bend and break. I've also put a fair bit of super glue around here, because the layers were splitting on this PLA that I'm using, which is rubbish. So that's stiffened it all up. So now we can actually wind it in one direction rather than going backwards and forwards. That means that I can get away with the single diode rather than doing a rectifier bridge, because if we're just turning it in one direction, then we're just getting the current generated in one direction. And if I turn it on, you'll see we have light already charged in there. So far, I haven't been able to run that battery right down, because it seems to automatically cut out when it gets fairly low, and then it restores itself a little bit if I just leave it alone. Anyway, we have light. Because we're using a solar light circuit board, when current flows into it, the circuit diverts the current to the battery and cuts the LED off. So a quick test: when we're generating current, the light goes out. It does come back again if I just give it a little turn. So that tells me we are actually sending charge into the battery. If we do it the other way, it has no effect. So if we're doing it the other way, we're not sending charge into the battery. Or the diode is doing its job. Well, I doubt whether the circuit would work in reverse anyway. So that's telling me in that direction we're not generating power in the right direction. Whereas if we do it the other way, straight away the LED goes out and the circuit disables the LED and sends the power into the battery. That lasts for about 20 seconds. I was going to say, if we haven't done any charging on it. But if I do absolutely nothing, turn it off and turn it back on again, because that battery still has some power in it, the LED lights up. So it's a bit difficult to actually, as I said, I could put some sort of load across there to actually run the battery right down and see if we can then charge it up afterwards. I probably ought to do that, shouldn't I? That'll be those two pins there. Just see if I can demonstrate what I mean about the battery restoring itself. If I go across the battery, so we put no power into it, but the nickel metal hydride battery is restoring itself. What we could do, are we off or on? That's on, that's off. Right, yeah, we're coming up to 1.15. See if there's any difference. 1.159. So it appears to have gone up a bit, but is that just because it's restoring itself? Because it's still going up. It is so difficult with nickel metal hydride batteries. I've got really confused in the past when I've been trying to demonstrate solar charging nickel metal hydride batteries. And if you just leave them alone, if they're in good condition like this one is, they pick up anyway. They don't fully recharge, but they pick up. .7. You could probably run it along the table like this, couldn't you? Put a wheel on it. Probably make a mark on my furniture doing this. That's an interesting idea, that. Put a wheel on there. Off a toy car. .77. Oh, I'll move that slightly. Yeah, 1. We are definitely going up. Yeah, I might have to think about that, whether we can put a rubber tyre on there. You can't put it straight on the gears. It'll have to be on the outside, and it can't be rubbing against there, so it'll have to be out the way. But then you could just do that with it. All ideas to think about. I've just given it about a minute of winding. See what we get now. 1.18 or 1.186. Yeah, we're really not shooting up in power, but it is positive. It is going up. Oh, that way round, isn't it? That's where the light is. I'm watching the timer on the camera, see how long it lasts for. Right, that's turned off. Let's see what it's dropped away to, or what its cut off is. Make sure we can see that. Oh, it's gone back on again. Turn it off. 1.09. And we were up to 1.18, weren't we? You see how quickly it's restoring. So difficult to tell. And just out of interest, if I put an LED across the battery, it doesn't light up. Because it's only, well, it's less than a volt. No, just over a volt, wasn't it? 1.1. Switch that back on again. Go the right way round. There we go. So that one's shorting out the white LED because it runs on a lower voltage. but across the battery's not high enough voltage, which is what the other bit of circuitry in there is for, that chip and the inductor, and what boosts the voltage up to what the white LED can light from. I think we've done this to as far as we can go, to be honest. I'm sure somebody will make some comments that I'll have to investigate, but I don't think I can go much further with this. So I could put a rectifier bridge on there so that we can turn it either way. And that would charge it up quicker than just turning it the one way. I think. .1, 1.12. One, 2, 9, 1, 3. But it restores on its own, so yeah, going round in circles here. Well, I had intended to stop there, but I thought I'd just show you this. This is how I was winding it. But it's just occurred to me, I want it to go that way. So if I do this instead, it's like having a big handle, because you're using the body as the handle. So that's what you call reverse logic, looking at it the other way around. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.